Good day, ladies and gentlemen. This is Physical Science, grade 11, term 2, our second discussion together. Previously, we spoke about the geometric properties of light, and we began by talking a little bit about reflection. Today, we are talking about refraction. Refraction refers to the bending of light. Now, the easiest way to illustrate this is if we have a block, be it a glass block or a perspex block, we then have light hitting this block. Now, of course, we have our normal, and what happens is this block as an optical medium is more dense than air. When light enters a more dense medium, it bends towards the normal. This is critically important when we talk about refraction. So this light ray would be continuing along that path, but it is bending towards the normal, so it will be moving like that. Now we have another normal, and now this light ray would be continuing like that if it were to continue on a straight line. When it goes into a less dense medium, it bends away from the normal, the opposite of what we have here. So it would now bend away from the normal, so it is going to go that way. My sketch over here is perhaps not the most elegant one, but it does illustrate the purpose. Another common example being a triangular prism. We have exactly the same thing happening. Light hits the prism, we have our normal. The prism is a more dense optical medium, so light is going to bend towards the normal. So rather than continuing on that line, it is going to move like that. Now we again have our normal over here, and rather than continuing along that line, it is now exiting, it is going into a less dense optical medium, so it is going to bend away from the normal, so it is going to go that way. And this, in essence, forms the crux of refraction. If you understand this rule, when light enters a more dense medium, it bends towards the normal. When light enters a less dense medium, it bends away from the normal. That forms the basis of refraction. Now, it has happened, or rather it most likely will happen, that you will need to illustrate refraction in some way. The triangular and square prisms, I apologize, are very common examples. What also happens is that they sometimes ask, what happens if you have your perspex or glass block and the light ray hits it at exactly 90 degrees? If the light ray were to hit the optical medium, in this case our block, at exactly 90 degrees to the surface, then absolutely nothing is going to happen. It is going to continue unobstructed. That is also just something to bear in mind. Now, this bending of light does bring us to the principle of a true and apparent depth. Anybody who does spearfishing, for instance, might know about this. Because if you have the surface of a water body, this then being air, oh, I can't spell anymore, air, and this then being water. If you as the observer are on this side and you are looking at a fish in the water, the way that light moves is going to sort of deceive you. Light moves into the water, it hits the fish, it gets reflected. So light is moving from the fish towards your eye. Now, when the light reaches the surface of this water, it would continue along that path. It is going into a less dense medium because air is less dense than the water. So it's going to bend away from the normal. So it is going to move in that way. Now if we extrapolate this line continuing this way, the fish is going to actually appear that it is there and not there. So the actual depth of the fish might be 3 meters below the surface. But because of refraction of light between the water and the air, the fish might only seem that it is 2 meters below the surface. And this is why I said somebody who perhaps does spearfishing might have heard of this. Because you cannot, if you, excuse me, you cannot, if you are trying to spear this fish, actually aim for where you see it. Because where you see the fish is not actually where the fish is in actuality. This is a very important concept in terms of refraction. A very easy way to illustrate this is to put a pencil into a glass of water or a straw. Very simply, all that you do is you have your glass of water and you put a straw in. Now what you may or may not see, depending on exactly how you look at it, is you will see that your straw is over there. But then when you actually look from the side, level with the glass, it looks like a straw is sitting like that. And that is because of refraction, because of the optical media, air and water, bending the light before it actually gets to your eye. I would encourage you to, for a homework assignment, get a glass of water and a pencil or a straw, and then put the straw or the pencil into the glass of water, and then keep it level with your eyes and see if you can observe this refraction. If you are perhaps so inclined, you might also do this with a glass of vegetable oil. Have one glass with water and your straw, another glass with vegetable oil and your straw, and see which one of those two refracts the light the most. Vegetable oil and water, of course, having different optical densities, so the refraction will be different. This is a very nice experiment that you can do at home without too much trouble, and if your mother or your father scolds you for spilling vegetable oil, simply tell them it is for science. Ladies and gentlemen, this is all that we are going to discuss today. Our next topic of discussion is going to be refractive indices and how they differ. and the influence that they can have on refraction. Obviously, we did need to talk about refraction before we did that. Ladies and gentlemen, if you have this, you are good for next time. Have a nice day.